Hello, today I want to talk to you about absolute value inequality word problems. Let's get right into it. So, I think probably most of you are familiar with the situation of you're at some kind of theme park or circus or fair or whatever it is, and there's some situation where, according to someone, your height matters. Maybe there's even like a ruler that says how tall you have to be in order to do something. And we want to describe this situation mathematically. I mean, maybe you don't, but I do, because we're learning about this sort of stuff. So this situation, you might think, oh, it's just an inequality. There's like some ideal height, in this case 60 inches, that I'm supposed to be. And if, let's see here, if my actual height is greater then I'm good. And that's the whole situation. And that might be how it is. But frequently, there's this extra concept in real world problems, which is called tolerance. And if you've gone to a lot of amusement parks or theme parks, you might have experienced this phenomenon, which is that frequently, if you're close enough, and if you make the right face, you don't actually have to be as tall as the ideal, or greater than, I don't know if that should be greater than or equal to or not, but frequently if you're very close and you make the right face, that's also good enough. And so I wanted to define this term for you, tolerance, maybe you've heard it already, as, let's see, it's the range of acceptable values. That's actually kind of inaccurate, but that's usually how it's defined. But anyway, so it's like, you know, if there's a certain amount, like if there's an ideal, but it can actually be off by a little bit, that situation is often described by tolerance. So we might modify our initial simple situation here a little bit. And the way I would modify is I would say that, in fact, what frequently is happening here is it's more like this. Where the tolerance might be like an inch or something. So if you're, even if this is slightly less, did I do that right? Yeah, so even if it's like this, if the tolerance is, I guess I'm going to put this the other way. Is that right? Okay. So, if I'm supposed to be 60, but I'm actually 59, as long as that's less than the tolerance, which might be, I don't know, 2 inches, I still get to go on the ride. And that's true in this case, I think, frequently. It's also true in lots of other real world cases that, like, you know, you have something, you're trying to make a certain size or a certain way or a certain number, but it's off by a little bit, it's sort of good enough. That's frequently true in a situation where you're building something. For example, if you're building like a deck, say, it's your ideal deck, and it's supported by wooden posts, perhaps. Okay, and these posts are sitting on the ground. It appears. But what you may or may not see is that the posts are sunk into underneath the ground. Giant pieces of concrete. So that over time they don't move. And now, when someone made that deck, I don't know if this illustration is helpful or not, but when someone made that deck, they had to pour that concrete. And frequently what happens, I can tell you, when you're pouring concrete on the ground, is that the ground is not level. So if you just pour your concrete right up to the level of the ground and sink all your posts the same depth, you wind up with a deck that's got all kinds of twists and bumps in it, so it doesn't actually work. So what you try to do is you try to somehow measure the height of these two, of all four of these chunks of concrete, and try and get them at the same exact height. And it's pretty darn near impossible to get them all at the same height, but it doesn't have to be perfect. It just has to be good enough. And you might describe that situation something like this. And this is an example of an absolute value inequality, where you might say it's a situation where we're not just concerned with the tolerance in one direction, we're concerned with the absolute tolerance. Because if one's a little bit higher and one's a little bit lower, that's sort of fine. It's just like we don't want any of them to be off by more than a certain amount, generally. And so, you know, if you're building one deck, you might just say, okay, I want everything to be within half an inch, and you just kind of eyeball everything, and that's fine. But if you're building, you know, many decks, if you're a deck builder, you might know precisely, like, oh, yeah, my tolerance in this situation is this amount for this reason. And you'd be thinking about it a little bit more mathematically. So it might be something like, I don't know, I want my actual, the height of this part of the deck to be, you know, precisely ideally 24 inches off the ground, or off the, you know, where all the other ones are, whatever. And so there might actually be some kind of variable like A. And I know that, you know, if they're more than a quarter of an inch off, it's going to screw up my whole thing, and the person I'm building the deck for is going to be real mad. So maybe you have some kind of equation in your mind like that you're working with. So I'll just walk you through the way this equation works. Is, you know, there's going to be some value here, whatever the ideal is, you're going to find the difference between the actual and the ideal, and that difference is going to be, you know, however much you're off by. If you measure, oh shoot, this one's, you know, 26 inches, and it's 26 minus 24, so it's 2 inches, which is not less than your tolerance, so, you know, that didn't work. You need to go back and make another cut on your board, or try and mess around with the concrete or something. So that is how that works. Let's see. There is also sometimes situations where, and this probably would apply in this case too, where it's not just like a certain value that things need to be off by, but it's more like a percent of the whole thing you're dealing with. And so in that case, you might have a situation more like this, where it's actually a little bit more like this. So that probably would have also been true in the deck situation. So like the bigger your deck is, probably the more variance you can actually have, because that like variance will be spread out over a larger area. So if your deck is like really, really long and on one corner it's an inch higher than the other, it's not as big of a deal as if it's like a very tiny deck and one corner is an inch higher than the other, because the slope is going to be bigger. So frequently what you're really dealing with is something more like this, where the difference between the actual and the ideal matters, but it's sort of proportional to the ideal multiplied by some small percent. Like maybe it has to be within 1%, so you'd have something like this. 1% is 0.01, I don't know. Hopefully that was covered for all of you in pre-algebra, but if you multiply whatever it's supposed to be by 0.01, that'll be 1% of whatever it's supposed to be. So this represents a situation where whatever you have needs to be within 1% of what it's supposed to be. Okay? I hope that makes some kind of sense and helps you on the assignment today. I don't think it's too tricky, but